Por favor, André, ten el placer.
Nada, quería hacer una pequeña intro de Sebastián, cómo lo conocí. Creo que de lo que mencionó Raúl al inicio en su charla, que es parte de hacer ¿qué es lo que hacer comunidad? Pues yo como parte de seguir investigando y conociendo más gente, me agregué a un grupo de comunidad de Francia y fue ahí donde le escribí a Sebastián, hicimos contacto por LinkedIn y ahora es parte ya de invitado de la comunidad de Perú y comparte mucho conocimiento. De hecho, él hace muchos blogs también para AWS y tiene también su podcast en francés, que bueno, los que estudian francés, los que quieren estudiar, pueden escuchar algo de tecnología en ese idioma, así como hay en inglés y en español. También Sebastián contribuye con un podcast en francés, ¿no? Y bueno, el día de hoy nos va a aportar sobre DevOps con CDK. No sé si Sebastián está conectado ahí, Carlos. ¿O lo tenemos?
Sí, está esperando, estaba viendo el ceviche.
Okay.
Hola, ¿qué tal? Can you hear me? Yes?
Yes.
Perfect.
I can hear you well, Sebastian. Nice to see you again in our community.
Thank you for having me, and I love the ceviche, so that's one more reason for me to visit you in person as soon as the world will reopen.
Yeah, I hope you like what you see, like making of a ceviche in a live stream. I think in technology, on in live stream technology, we didn't see nothing like that, but it's like a fresh break before this great talk that you were going to give you right now. So for everyone, I'm going to say this in Spanish. Para todos, Sebastien es Principal Developer Advocate en Francia, en París. Y pues va a hablarnos de un tema muy interesante que es para los que estamos metidos en infraestructura como código. Nos va a hablar sobre cosas avanzadas de CDK, ¿no? De CloudFormation SDK. Así que sin más ni menos, Sebastien, this audience is yours, and you can start your presentation right now.
Muchas gracias, Carlos. A mí me gusta. So, yo no va a hablar en español poco, porque no tenemos tiempo. It will be way too long. I still have to practice my Spanish. So thank you for having me here today. And yes, in the next 30 minutes, I will show you how you can take benefits of the CDK, the Cloud Development Kit, to build your infrastructure. So I can switch to my slides. Oops.
Of course, Sebastian.
Like that?
Yeah, that works very good. Your Spanish is very, very good.
I'm learning. I'm taking class every week. Thank you to my teacher. That's my objective for the end of this year, to make a technical talk in Spanish.
Wow, great. That's a great goal. Keep going. Let's go.
So this is a advanced talk, what we called level 300 type of talk. So I will not go into the details. I'm not going to talk about infrastructure as click. You know, infrastructure as click is when you go in the console and you click there, and you build your infrastructure with clicks. And there is wrong about that. I'm building infrastructure as click as well. That's the best way to discover a new service and to start to understand the new services. But when you're serious about deploying on AWS and going to production with your infrastructure, you need something more robust than just clicking in the console. What if you need to replicate your environment in test, dev, production, or replicate your environment on multiple regions, for example? So I will not give you reasons why you should use infrastructure as code. I will not tell you that it's super good because it's repeatable, because it's testable, because it's a formal documentation about your infrastructure. A customer told me the other day, it's great, I can have all my data center in GitHub, and I can version control my data center. And this USB key is my disaster recovery. I can recreate my data center with a script which lives on that USB key. That's the advantage of IAC. I will not tell you how to get started with IAC. It's been 10 years now that we have released CloudFormation, and CloudFormation is probably the way to go for infrastructure as code. As you probably know, you write JSON or YAML templates, and you give them to CloudFormation, and CloudFormation, quote, quote, execute these templates for you. It will figure out the dependencies between the different services and bring you infrastructure. And over the year, we have bring tons of stuff to CloudFormation. You can deploy to multiple accounts very easily. You can connect it with AWS organization. So when an account is joining your organization, it automatically deploys some basic infrastructure such as networking, connectivity, security, logging, for example. I will not show you tables like that. It's not in this talk that you are going to see this type of table that try to compare the different solutions that exist. Of course, there is CloudFormation, there is the AWS CLI, maybe you can write a shell script. There is Terraform from HashiCorp, there is serverless from serverless, there is SAM, and there is the CDK. So no, I'm not going to talk about that in this talk. In this talk, what are we going to talk about? I'm going to tell you the story of a guy that since 10 years is building infrastructure with CloudFormation. He started with JSON, he moved to YAML. I'm that guy. Maybe you are that guy too. You are building solution with YAML, and you write a lot of YAML code to feed CloudFormation. CloudFormation is actually very, very low level. It's a one-to-one match with our API. So when you are writing CloudFormation, you need to take care a lot about small details about, I don't know if you try already to create a network with CloudFormation, but you need to create a VPC, the subnet, give the IP address range, create a gateway, attach the gateway to the subnet. You need to create the routing table, attach rules to the routing table, then attach the routing tables to... That's way too complicated. So it's the story of a guy that decided to check another way to write code to provision his infrastructure. And that code can be based on high-level programming language, the one that you are knowing already, that you are using already: Python, JavaScript, TypeScript, Java, C#. So yes, now you can write code that will generate your infrastructure, that will provision your infrastructure in the cloud, using high-level programming language. So in the DevOps world, if you are a bit more dev than ops, you will love that, because using the same tools, the same IDE, you can know, and then the same programming language, you can know write your application and also write the code that will generate your infrastructure. This is the Cloud Development Kit, AWS CDK. And the idea of the CDK is to provide you with a command line interface that will execute the source code that you are writing. It might be code in Python, in Java. You create an app there, then you create your stack. Yes, the same stack as CloudFormation. And inside your stack, you create resources such as an S3 bucket, a Lambda function, a database, a network, a cluster to host your container. So the CLI, the command line, execute the code that you wrote in the script. And we are not going to reinvent the wheel. We already have CloudFormation. So what the CLI does at the end of the execution of the code, it's to synthesize, to generate a CloudFormation template. And then it will execute that template. It will deploy that template for you in the, it will provision. So for example, if you want to create a network, if you want to create a VPC, this is a JavaScript, or to be precise, this is a TypeScript example, but you can write the same in Python or in Java. To create a network using the CDK, it is just these two lines of code. You declare a variable VPC, you create an object called ec2.vpc, you give it a name, and then you give a couple of properties, and the good news is that most of the properties are by default. So here I'm just changing the number of availability zone where I want my VPC to live. And this simple lines of code is going to create a VPC with a private subnet in each of availability zones, so 2 private subnets, with a public subnet in each of the 2 availability zones. It will create a routing table to glue all these things together. It will create a NAT gateway so that your private subnet can connect to the internet. All the stuff that you need to do manually one by one if you are writing your CloudFormation code by yourself. So these 2 lines of code generate what? Roughly 400 lines. Yes, these 2 lines of code generates 400 lines of CloudFormation code. If you want to get some assets from your directory to deploy a website, a static website on S3, for example, it's just 3 lines of code. If you want to create an EC2 instance and pass to that EC2 instance a shell script to bootstrap your server, to initialize all the package when your server is going to be boot. This is known as user data on Amazon EC2. This is as simple as creating a user data object for Windows or for Linux, and then you add the list of commands. And because you're in a programming language, you can have variable, you can inject values from your environment, you can loop, you can make conditions, for example, on this script. A more complex example, I want to create an auto-scaling group. You know that to create an auto-scaling group, you need to create launch configuration, give the type of machine, give policies for scaling up, scaling down, and so on. You can create an auto-scaling group with just 1 line of code. 1 line, new autoscaling.autoscaling group, you give your name, and then you give a bit of data, the minimum set of data that autoscaling needs to know to create a new machine. So in which network, of course, what type of instance it needs to launch, what type of AMI, the machine image, what is the desired capacity, how many machines should I start, and optionally you can pass a role or a user data. These are optional. The 3 first are not optional. VPC, instance type, machine image, and desired capacity. And that CDK code in TypeScript here will create all the infrastructure that you need in a CloudFormation template. So what about CDK construct? You know that people that love, men and women that love to write code, we don't like to write the same code over and over again. So we try to encapsulate code in higher level construct. You can call it objects if you're programming in Java, or classes. You can call it libraries if you're programming in Python. But the idea is the same, is to build a set of tools, a set of lines of code that you're going to reuse from one project to the other. And the big strength of CDK is that it provides a lot of high-level construct. The VPC, for example, it's a super high-level construct. 2 lines of code generates 400 lines of CloudFormation. It's a pre-configured way to create a VPC. And you can create your own construct as well, just like in any programming language. Construct can be super powerful. For example, this construct called a pattern, it's much more than just a couple of services that we put together. It's the encapsulation of best practices, design patterns that you can use inside your application, leveraging years of experience we have to build highly available and resilient system, leveraging the feedback from thousands of other customers. We built into the construct a couple of these best practice and patterns. For example, this application load balanced Fargate service is going to create a cluster to run your containers with a load balancer in front of it, running on a Fargate. So Fargate is our system that allows you to run containers without having to manage any virtual machines underneath. The only parameter you need to give us, the only mandatory parameters, is the name of the Docker image that we are going to use to deploy your containers. So with 3 line of TypeScript, codes. You create a full cluster in a VPC, in a region with a load balancer in front of it, and we start to deploy your service there. So a construct, it's really the capture of a best practice. It might be as simple as a VPC, like in my first example, or as complex as a full implementation and design patterns. The ones we do provide are quite generic for most of the use cases, but of course you can create your own for your own company. What is a VPC inside your company? What is the connectivity with Transit Gateway? What a load balance Fargate service looks like in your company? You can build these constructs yourself and distribute that to the rest of the developers so that everybody is using the same baseline construct where everybody can actually leverage your construct library to build the same infrastructure across multiple AWS accounts or across multiple regions. Just to finish on that specific construct, it's 800 lines of code that are generated with these 3 lines of code: the full VPC, the load balancer with the security group, the Fargate service with the correct permissions, the IAM roles and policies, and the ECS task definition where we're actually going to run your container. And that's quite impressive. So let's look at what it takes for you to build your own construct. Let's take an example. EC2, for example. With EC2, there is no construct provided by the CDK. So when there is no construct, it defaults back to CloudFormation. And it's a one-to-one mapping between what you can find in CloudFormation and the CDK. And these are these classes, as you can see there somewhere, CFN instance. When it's prefixed with CFN, it means that it's CloudFormation. So it's really low level. It's one-to-one mapping with CloudFormation. So if I want to create an EC2 instance by myself using the CDK, I create a class with whatever is provided by the CDK, CFN instance. And you see it's quite low level. There is no type, for example. Most of the parameters are string, which is not a good thing. If you're developing, you know that having a strongly typed programming language can help you to catch many mistakes at compile time instead of catching this mistake at runtime. If you catch them, most of the time it's just blow up with a stack trace, and it's up to you to figure out what was not working. So what do we need to start an EC2 instance? We need an image ID. Okay, that's an image ID, AMI123, an instance type as a string. We need to let EC2 know in which subnet it has to work. For example, the subnet ID, but notice that the subnet ID is attached to a network interface where you need to give a device index. Wow. What about user data? User data in CloudFormation needs to be base64 encoded. So how do you base64 encode? You can use fn.base64 and then give your bash script as a string again. If you want to attach an IAM role, you need to create a role by yourself and give the ARN as the IAM instance profile. So super low level. It's not bulletproof. You can do tons of mistakes there. You can get the wrong AMI ID, the wrong instance type, or forgot to use network interface to pass the subnet ID, and so on and so on. So instead of that, I'm going to construct my own construct. I'm going to build my own EC2 higher level construct. And the first thing I'm doing is to create a data type. I call it a prop, but it can be called anything, which defines what is an EC2 instance. And I define 5 properties, the image type, and I give a type to these properties. Instead of using string, I'm using the types that are provided for me by the CDK. So an image, it's an EC2 machine image. An instance type is an EC2 instance type, and so on. User data of type user data, subnet of type subnet, and role of type role. And now I can extend the generic class called resource, and I create my own class, EC2, my own EC2, your company EC2, for example. And in the constructor, I pass the properties, the EC2 instance prop that you just showed on the slide before. And then I extract the value that I receive from this prop to extract the string that the low-level CFN instance is actually expecting. So in my construct, in my higher-level EC2 definition, I encapsulate the properties defining an instance, and I call the low-level CFN instance class, giving the image ID as a string, the instance type, and so on and so on. Once this is done, once for all, I can also add some predefined behavior. For example, in my company, they say that every single EC2 instance which I start need to be tagged. They have to have a name. So I can add that into my constructor, and so I will not forget anymore to add a tag to an instance. So I add additional value or additional behavior on top of the class definition. And once this construct is done, I can distribute that library to the rest of the developer in my company. And all developers in the company now can just say, hey, if I want to create an instance, I type new EC2 instance, I give a name, and then I use high-level object like image. I say it's an Amazon Linux image. I don't need to remember which AMI. This thing will automatically take the latest version of Amazon Linux 2. Same for instance type. I don't have to remember the fancy name T3.micro, P4D.24XL. No, I just say it's an EC2 instance type of that class, like the birth table, the T family, or the C family, and which size inside that class, micro, large, XX large, and so on. Same for the subnet. I don't need to remember it's a sub-attribute of a network interface. No, I just give a subnet. I give a role, and I give a user data similar to the user data object I showed you in a previous slide. And that class will extract a different value, call the underlying CFN instance, and generate the code for me. So that's one of the great things about the CDK, is that you can encapsulate behavior properties in higher level construct. We do provide a couple of constructs, but you can generate your own construct as well. But what else? Remember, it's code. It's Java code, it's Python code. So why can't we leverage all the best practices I learned over the years to have continuous integration, continuous deployment, and unit testing? There is a nice library called Assert that allows you to do unit tests on your infrastructure code. And there are two types of unit tests. The first one is snapshot. So you create your test, you import the stack and the Assert library, and the test will be, this is a code, a stack that generates a dead letter queue, an SQS queue, and you want to verify that it creates an alarm. So I create my stack, I create my dead letter queue, and then I say, whatever is going to be generated by the CDK, so the CloudFormation stack that will be generated by the CDK, I want it to match a predefined snapshot. And a snapshot, it's like a picture of what the ideal or the target CloudFormation stack should be. So the very first time you're going to run that, it will create the snapshot. And every other time you are going to run that code, it will compare the code, the CloudFormation code, which is generated by your code, with the snapshot. And if it is the same, the test match, and you can continue. If it is not the same, it's going to generate an error. So this is how it works. You type npm test, and first time it write the snapshot. You can see there one snapshot written, and then it's going to test, and I have 2 test suites, 3 tests passed, 1 snapshot written, and everything is well. If I change something in my stack, like changing a name, for example, the snapshot which is stored under that location in your test directory, __ snapshots, then you will find the snapshot. And you see the snapshot is just a CloudFormation template. So if I change something in that code, the test again, here I change the description of a resource. The description does not match what is stored on the snapshot. So the test will fail and say, hey, this line in the template is not the same as the one on my snapshot, and it even gives you the exact line of the test that failed. So snapshot testing is interesting, but it's not very flexible, because sometimes you want a bit of flexibility to change the name of things, to change the comments or whatever, and you still want your test to work. So depending on what you want to test, you might want finer grain control on your test. And there is another way to test. It's called expect CDK to have resource. So here in that test scenario, you're going to test your CDK generated CloudFormation stack to actually verify some properties inside the stack. And a property might be, I want that stack to have a queue. I want that stack to have an SNS topic, for example. So the way it works is the same. I have two tests here. The one on the top tests that a queue is created. So I create my app, I create my stack, I create my demo stack. And then I start to validate my assertion. I expect that SDK stack to have a resource called AWS : SQS : Q, which is the little friendly name that we are using inside CloudFormation to say, I want an SQSQ. And that assertion will be true as long as you do not remove the Q resource from your CDK code. In the second example here on my right side, I want to verify that there is an SNS topic created. And it's the same. I create an app, I create a stack, and then I start to test my assertion. I want to verify that that stack have a resource called AWS SNS topic. So I hope I convince you to start to use the CDK, especially if you're Python, TypeScript, JavaScript developer. You will find it much easier to generate code than using raw, low-level YAML templates for CloudFormation. And you can apply all the best practices you have in terms of CI/CD, unit testing on your infrastructure code. So let's show you a couple of examples. I want to create an infrastructure with a Lambda function that fetch event from a queue and generate logs into CloudWatch logs. So I need two resources, SQS and Lambda. I need permission for Lambda to fetch event from the queue, and I need permission to Lambda to write to CloudWatch log. How can I write that using the CDK? So first I need to write my Lambda handler code. So that's the code that's going to run inside your Lambda handler. It's the same if you are using the CDK or SAM or CloudFormation or even the console. You need to write code like that. And let's have a look at this code. It's quite short. The first thing is to lock the event that has been received. I recommend you to do that. It's a best practice, so you see the exact JSON that you receive in your Lambda code. Then I create a DynamoDB client, and for each record that I receive there, I will put a record into a DynamoDB table client.put with the table name received as an environment variable and the item as an ID, a text, and a body. And of course, it's asynchronous, so I return a promise and I have the await keyword. You're familiar with that if you're developing with TypeScript. So no SDK part. First, I create. Sorry, the CDK part, not SDK, the CDK part. First, I create the queue. SQS.queue, I give a name, demo01 queue. Second, I create my Lambda function, new Lambda function, and I give three parameters to my Lambda function. The first one is the runtime. This is an OGS runtime. The second is the code asset. So it's the directory on my project where the code that you just saw before is living. And I give the entry point into that function, index.handler. So 4 lines of code, I create a Lambda function, plus 2 lines for the queue. Then I need to glue all these things together. First line, I add an event source based on the queue to my Lambda function. So fn is my Lambda function, add event source, and then I create an SQS event source based on the queue that has been already defined. But remember that my code also writes to a DynamoDB table. So I need to create a DynamoDB table, and I have to give my Lambda function enough permission to actually write into that table. So I create the table with new DynamoDB table, and I just need to give one attribute, its partition key, so it's the index of that DynamoDB table. Then I need to pass the table name as an environment variable to my Lambda function, and that's table name there, one line of code. And because I'm in a dynamically running execution environment, I can take the attribute table name that has been generated just before and pass it as a variable to another function. And then I need to grant my function the permission to actually write on the table. So table.grant write data to the function. And with these 1, 2, 3, 4 blocks of code, I glue all my things together. I have my queue, I have my Lambda function, and then here on this one, I first create the event source, the DynamoDB table, and the authorization to use that DynamoDB table. When I want to deploy that, I type CDK deploy, and it will output a list of all the resources that are going to be created for me. It asks me if I am okay with that. I click yes, and I wait a bit. It depends on the complexity of your script, but here it takes like 1 minute, 1 minute and a half, and it creates the stack for me. At the end, I can go to the console. I see that there is a demo01 queue that has been created. I can write a message into that queue, a JSON message, hello world. Then I go to the DynamoDB console. I see that the table has been created in DynamoDB. And look at that on the bottom of the screen there. There is an item that has been created for me with message string hello world. So it looks like my Lambda function is working and correctly received the message and wrote the message into DynamoDB. What about more complex things? I hear you saying, it's nice, but it's easy. It's a simple example. So let's create an ECS cluster in a VPC with a load balancer. I showed you the construct for that before, but this is the infrastructure we are going to create. A VPC with public and private subnet. In the public subnet, a load balancer that will dispatch the load to a cluster of containers running on Amazon ECS Fargate. First, I create the VPC. 2 lines of code. Then I create my cluster, 2 lines of code. I pass as an argument, you can see there, the VPC that I just created before. Then I need to tell, hey, this is my repository. I will use ECR, the Elastic container repository from AWS. And then I will use a high-level design pattern, the construct, application load balanced Fargate service. And I need to pass 4 parameters. First one is the cluster that we create on the previous slide. The second is the runtime environment for my containers. How much memory, 1 gigabyte, how much CPU, and what is my task, what image I'm going to use. And I use from ECR repository, and I fetch the latest image. It's probably not the best practice to use the latest image because at each execution might be a different one. Best practice would be to use a specific version number. Once again, CDK deploy, it lists all the service and the resource that are going to be created for me. If I agree with the change, I wait a bit. This one takes a bit longer because creating the VPC is longer. Created the ECS cluster, it's a bit longer. But after a few minutes, after a ceviche, after a coffee, I can just go and I receive the URL of my container, of my load balancer, and I can immediately test the load balancer by copy-pasting that URL into a browser and see that my application, okay, it's a very simple application, has been deployed to that address. So, wow, CDK, TypeScript, JavaScript, Python, Java, C# to write your infrastructure code in a very, very short lines of code thanks to construct. You can build your own construct to encapsulate the best practice inside your company, and you can apply all best practices from software engineering, like unit testing, like continuous integration and continuous deployment and versioning inside Git, to store this type of CDK. If you're trying any of the example I show you today, don't forget to do CDK destroy. So CDK destroy will delete the stack. And after that, it will actually delete all the resource. So be careful as well if you are using this. But if you are using CDK just for testing and just for learning, don't forget to use CDK destroy to be sure that you are not paying for resource that it's not necessary to pay. If you want to go a bit further, you can, this one is in French. I forgot to translate that one. You can try the workshop. It's cdkworkshop.com. You have a TypeScript, Python, .NET, and Java workshop to go into more details into the CDK. So remember to not do infrastructure as click. As soon as you are over with the learning phase and you know about the service, write script to build your infrastructure, because this is repeatable, this is testable, this is versionable. So don't write infrastructure as click, but instead you can write infrastructure as TypeScript, as Python, as Java, as JavaScript, YAML maybe with CloudFormation. But remember only one thing, write infrastructure as code. Thank you. That's all for me. I'm just in time. I have a little present for you. If you give me a little present, your little present will be your feedback. I value your feedback. I want to learn how to make this type of talk much better. So you can go now on eventbox.dev and type that code. Or if you don't want to type, you can just scan the QR code. It will bring you to that URL. The QR code is safe. I built it myself, so I will not bring you to a nasty place. You give me feedback about this talk, and if you give feedback, you might receive an AWS service credit for $25 US. It will be valid until the end of March. You bring the code inside your AWS console, and it will be $25 US saved on your next AWS bill. I'll let that on the screen, and I'm happy to take question. Actually, I will have a look at the question. So I didn't look at the question at all while I was I was talking. Sorry for that. Is it possible to assign specific names to resource instead of auto-generated ones? Yes, it's possible. It's not a best practice, because if you want to repeat the execution of your stack, like for example, creating a test environment and a production environment in the same account, in the same AWS region, if you hard code the name of the resource, you might have name conflicts. So it's better to, and it's very easy to do with the CDK, to prepend. So to add at the name of the environment. For example, you have a dev environment and test environment. So you will have -test or -dev or -prod so that you can identify your resource. Of course, you can tell me also that it's not the best practice to have your test and dev environment in the same account, in the same region, and you're correct. Maybe it's better to use different account for that, in which case hard coding names is perfectly valid. Next question, how can we use the output from a stack in another CDK? So it depends, and I'm sorry, I don't have a nice answer for you there. So remember, in CDK, you have the concept of an application, and an application is made of several stacks. For example, in the last application I did, I had one stack for the network, one stack for the database, and one stack for the code. So it was three different files in the same application. As long as you are in the same application, it's quite easy to pass parameter from one stack to the other. So you can take the output of one to the input of the other one, because it's one unit of execution. It's the application. If you have multiple applications, sorry, there is no easy way to do that. You need to capture the output from one and pass that as a parameter to the next one, just like you would do parameter passing with a regular application. So it depends how you structure your stack. Stack inside an app, you can do it. Stack in separate CDK app, you need to to find another way to pass your parameter. How is currently the experience creating serverless application with CDK and stop using serverless framework? I have mixed feeling, to be honest, about that. For serverless, I much prefer SAM. And I'm not saying I prefer SAM over serverless. Serverless is great, and there is tons of plugin and a great community developing serverless. But at AWS, we have something equivalent called SAM, Serverless Application Model. And if the goal is just to create a Lambda function and a couple of resources, I found SAM most of the time being enough for my needs. I like to resort to CDK for more heavy work, like VPC, databases, complex resource, complex dependencies between the resource. The example I gave with a database and permission, maybe it's where CDK can be a bit more efficient than SAM and serverless as well. So it's really a matter of preference. It depends on how many dependencies you have, how many resources you have. If you have a lot of resource, CDK, it's more heavy lifted, more powerful. If it is just a small Lambda function with a DynamoDB table, maybe SAM or serverless is doing the right job. I think there is a matter of preference. And to be honest, in my last project, I mixed the two. My low-level infrastructure, network, database, load balancer, and stuff like that was in CDK. The serverless infrastructure, I did it in SAM. Why? Maybe preference. I could have done everything in CDK. I could have done probably everything in SAM, but that would not be a good idea, because then you resort to VPC in SAM, which is CloudFormation. So, but yeah, I could have done everything in CDK. Why did I split? Good question. I have to make a deep introspection inside me to find why I did that. Question about testing. I see we are creating a new stack for each test. Can we create the stack once and use it in all the tests? Would that be faster? Yes, you're correct. My example is not optimized. My example was to be more on the pedagogy side than on the optimization side. But of course, you can create the stack once for all and then test your assertion on the generated stack. It will be faster, no question about that. That being said, generating the stack is the fastest part of CDK. What takes time is to actually deploy when we need to create a resource. But just generating it's executing your code, generating CloudFormation template, it's super fast. It depends how many tests you have. If you have 2 or 3, maybe you are not going to feel a big difference. If you have hundreds and thousands, of course, do that. My example was not optimized for speed. It was optimized for leasability. CDK vino para quedarse. Han trabajado ya con CDK. If you work with CDK, let me know and share your experience with the rest of the community. Pero siendo desarrollador, se entiende mejor que viva el código. See, I wanted to create a talk with code, and real example. If you notice, there was more code than slide in my talk. Someone talked about CDK and Terraform. Yes, Terraform as a module for CDK. So if you are using Terraform, now you can use CDK to generate Terraform. I never tried that, but that's possible.
Wow, great, Sebastien. I think
I'm still looking about the naming question. We talk about that, and indeed, if you need to conform to some naming standard, then you can implement your naming standard inside your CDK code.
Okay, great, Sebastián. Everyone, I'm going to switch to Spanish. Cualquiera, por favor, entren a ese link que han compartido en la comunidad. Aquí los voy a poner en la pantalla. para que puedan valorar la charla y que pues, puedan entrar a créditos de AWS de $25. Y también nosotros tenemos una sorpresa. We have a surprise also. For the end of this, we have a few vouchers for AWS certification. For the first exam of all, this is the cloud practitioner. So maybe we have to give away a question, Seb, to the one who answered first. You know how it works. So I'm going to switch to Spanish to everyone. Tenemos voucher de certificación y vamos a empezar con el primero, ¿sí? Con la primera giveaway de voucher de certificación. Así que vamos a hacer una pregunta. Obviously, we don't have to make a 300 level questions for the cloud practitioner certification because we have to just go down a little bit on difficulty on the question, maybe a level 100, level 200 question. And the first one, el primero que pueda responder, será el primer ganador de este voucher de certificación, ¿no? Algo, sé que es complicado, it's complicated for the people who just starting in learning about CDK or CloudFormation, but vamos a ver. Let's see what happens. So, do you have a question in mind?
No, I'm thinking about that right now. I'm trying to to think about it. A simple question about a true or false question is maybe too easy. A question about the CDK, an easy question about the CDK.
For example, any the limitations may be about CDK. No, it's too easy.
I'm looking at the CDK page as we are talking. Let's make true or false question. Preguntas con false or true about in you translate to Spanish for me. the CDK code runs natively in the cloud. True or false?
El CDK corre nativamente en la nube, ¿verdadero o falso? CDK runs natively on the cloud, true or false? So that's what you said, right?
Yes, but maybe I was not. I see all the answer. And actually, the first answer.
The first answer was this.
Is this, but the way I ask the question, the correct answer is false. The CDK code does not run in the cloud. The CDK code runs on your laptop and generates CloudFormation that will be executed in the cloud. Is it too hard?
Let's see who's the one.
And the first false is from
David's.
No, there is one before.
See. Oh yes, Jace is.
Yes,
oh my God, Juan. Juan,
1, 2. I'm sorry.
Wow,
but it's an important concept, and to repeat on that one, the CDK code is going to execute on your laptop, generate CloudFormation, and then the CDK command line will pass that to CloudFormation that will execute it in the cloud.
Wow, that's
So,
one of the yeah, great. That's for Juan. Congratulations, Juan. Felicitaciones, Juan. Qué bien que te llevaste un voucher certificación. Si ya tienes el voucher, o sea, si ya pasaste el examen, pues puedes donarlo a alguna persona que tú creas conveniente o pues simplemente para ti, ¿sí? Así que escríbenos, por favor, a nuestras redes. Es una persona que ahí lo conozco, así que no tiene nada que ver con eso, así que me escribe Juan y ahí te pasó el voucher de certificación. Va a haber 2 vouchers más durante la tarde, así que van a tener oportunidad también a los que recién están empezando. ¿Sí? ¿Lo vas a usar? Súper, excelente, entonces, Juan. Excelente, sí, va a haber más. Bueno, creo que estamos bien con la hora también, así que muchas gracias, Seb, lo hemos pasado genial. La verdad que yo aprendí muchísimo, espero que todos hayan aprendido muchísimo acerca bueno, es una charla realmente avanzada, pero nos deja mucho porque a los que estamos metidos en infraestructura as code, tenemos una muy buena opción ahí, ¿no? A lot of people tell me about what is the best benefit of CDK instead of using serverless framework. I think there's a lot of people questioning that. So why, as the final question for you, Seb, why I have to use CDK and CDK pipelines maybe just to make all the infrastructure works very great, very good. Instead of using serverless framework, instead of using Terraform, or what is your approach? Mixing or just using only one platform?
Yeah, that's a good question. And actually, you don't need to use CDK. If you're happy with Terraform today, continue with Terraform. I'm not telling you to switch from one to the other. We think that, to build a house, you need multiple tools. And you need one tool for each task. And there are some tasks for which CDK is really shining and really good, like creating ECS cluster, creating network. So creating all these low-level infrastructure. You are not going to create an ECS cluster or VPC using serverless framework or using SAM. But you might using Terraform, of course. That's why Terraform is for. So if you have already invested a lot in Terraform and you know Terraform and you have your tools and your tool chain already set up, stay with Terraform, especially that you can even do CDK with Terraform. But if you are new and you know already how to program in Python, you know already how to program in TypeScript or in Java, why would you learn another programming language, like Terraform programming language? Maybe you want to just leverage on your IDE and continue to use the programming language that you love and that you are using every day. Remember, using a real programming language, or I should not say real programming language, using a high-level programming language compared to YAML, for example, gives you type safety, give you code completion when you are in your IDE. You can directly jump to the definition of a class, or you can directly see the documentation of a class directly from your IDE. And all these are performance, productivity gains. You will be faster to write your code. So I'm not telling that one is better than the other. It's a matter of preference. If you have invested in something, keep that something if you're happy with it. I'm not telling you to change. But if you're starting from scratch, maybe have a look at CDK.
Wow, that's a great answer, Seb. Well, with Mario, I think that subject that we talked today about CDK brings new opportunities, possibilities for infrastructure code in different languages. I love about that. And I hope everyone just have fun with this talk and maybe motivates to learn CloudFormation and CDK, instead of other tools. As you mentioned, it's not only the tool, is the thing that you maybe automate. It's the main thing. You have to automate your pipelines, your resources. That's the main thing. No matter what tool you have in front of you, but if you have the right tool for the right job, it's better. As you said.
Much easier.
Much easier. Okay, I think that's it. Seb, have a big hug from here, from Lima, from Peru.
Congrats for the conference, for the lineup, for the speaker. The agenda is super interesting. I was watching since this morning, since you start with Jeff Barr. So great, continue like that.
Thank you, Seb. That's big coming from you, and I hope you have a great time here. And I hope it's